Hi, this is Dennis Myers. In this video, we're going to look at the Walk Forward Strategy Input with Metric Filters Explorer version 8X. The Walk Forward Input Explorer, for short, is a standalone 64-bit EXE program that is super fast and automatically displays its extensive statistical results in Excel. The Walk Forward Input Explorer reads all the files generated by the Power Walk Forward Optimizer and searches each Power Walk Forward Optimizer file for the best combination of strategy inputs and performance metrics filters that generate the statistically best out-of-sample performance. A strategy input filter summary is generated and sorted by total out-of-sample net profits after costs for all strategy input metric combination filters, examined and written to a comma-delimited Excel file. In addition, using modern bootstrap techniques, the Walk Forward Input Explorer calculates the probability of whether each strategy input and metric filter out-of-sample results were due to chance. When the Walk Forward Input Explorer is done, just click the Excel icon next to the Run button, and the Walk Forward Input Explorer output file will appear in your Excel. In front of you, you see the Walk Forward Input Explorer screen, which first comes up when you click on its desktop icon. When you first use it, most of the inputs are blank, and they need to be filled in order to run it. In this video, I'm going to look at the same files that I generated with the videos in the Power Walk Forward Optimizer, namely those Power Walk Forward Optimizer files generated the paper on my website in the papers section, trading the S&P 500 SPY 5-minute bars with the robust regression velocity strategy. In that paper, I used the Walk Forward Input Explorer to determine what the best filter was, and two, how it performed in the out-of-sample data. In this video, I'll show you how to set it up, how I set it up in that paper, and how to set it up in general. First thing we have to do is locate the Walk Forward files that we're going to examine. So we go up here to this folder icon, the green folder icon at the top. We click it, and originally it just puts you on the C drive because it doesn't know where your Walk Forward files are. But all the Walk Forward files that I have them on my remote drive in a directory called the Walk Forward data directory. As you can see, I have many different Walk Forward folders. We're going to look for the SPY 5-minute repeated median folder, which is this one. When I click on it, it tells me, okay, that's where it's going to get the data. Now I have to tell it where to put the data. And usually I'll put the data in my temp directory. We'll just go over here. We'll just put it in this directory also. As you notice that it automatically inserts a stub. It will do that if your folder name is the same as the Power Walk Forward Optimizer stub name. Here, this labels what particular run I'm using. If I'm doing many types of run, I label them A, B, C, D, E, F. The start file equal to 0 means that I want the first Power Walk Forward Optimizer file, and end file date of star means I want to look at the last. I want to go all the way up to the last file date. I don't have to actually enter the file dates unless I want to. As you'll see when I click the Run button, it'll automatically fill them in. If you don't want those, you would enter them yourself. The metric fields are blank. After you do a first run, all the data that you enter in these fields is saved. So when you do a next run, all this data pops right back up, and you can either change it or change one of the inputs, etc., etc. Anyway, for the first metric, I'm going to look at the profit factor, and I'm going to scan for the profit factors from 2 to 4 by 1. What this means is that it's going to first look at the profit factors less than 2, then profit factor is less than 3, then profit factor is less than 4 while it's running. The SPY has each file in the SPY 5-minute bars has 6,048 different inputs. What this means is that the input explorer is going to look at the in-sample portion, and it's going to take a particular, each one of those 6,048 inputs, one at a time. It'll take that input and see how it performed alone on the out-of-sample files. I believe there's 566 of them. Then it'll take that input file and examine the input and the in-sample data and test to see if the profit factor in the in-sample is less than 2. If it is, it will execute the out-of-sample data. If not, it won't. So that particular, there will be no trades in that out-of-sample data. Then it'll do it for profit factor less than 3. Then it'll do it for profit factor less than 4. So in that particular instance, we have 2, 3, 4, and none times 6,048 different inputs. So in that particular case, we got 24,000 different filters. The next metric I'm going to look at is what I call a KTOW. I'm going to look at all KTOWs less than 40 to 70 by 5. So in addition to the profit factor, it's going to look at the KTOWs from 40 to 70 by 5 for each one of the 6,048 inputs. So if in the first input, if KTOW is less than 40, it'll execute the out-of-sample. If it's not, it won't. Then it'll look at the KTOWs less than 50 or 45, all the way up to 70. And then it looks at the combinations of the profit factor and KTOW. So as you can see, there's many, many filters. In particular, I think there's 169,000, which we'll see when we hit the run button. We're not going to use metric 3, so it's blank, and a zero in the by column indicates we're not going to use it. We're not going to scan for minimum trades or maximum trades. This means that in the in sample, if the trades are less than 10, and I did happen to put by 1, then if the trades were less than 10, it wouldn't execute it. If the trades were more than 10, it would. Maximum trades means just the opposite. If I put this, I could have a range also. Put this at 1, then if the trades are in the in sample section are more than 50, it wouldn't execute it, the out of sample data. If they're less than 50, it would. Big file equals yes. This is needed so that when the run is done and there's a particular filter we want to look at, we can click on it and immediately see the equity plot. And we'll show you that in the second video, how to find a good metric filter in the walk forward input explorer output. TradeStation dupe lines. Usually TradeStation adds 2 extra lines to each Power Walk Forward optimizer output. And those lines were the maximum of whatever total net profits it found. We don't want those included twice, so we would put a number to exclude those. So I would put a 2 here. Multi-charge doesn't put those 2 lines in, so multi-charge would be a 0. Total net profits greater than 0. That's an added screen on the in sample. In other words, if the total net profits on the in sample are not greater than 0, we don't want to execute the out of sample portion. I usually leave that as no. I don't care about that. The other metrics will show me what I want. R2 is the correlation coefficient of the curve, of the out of sample curve. R2 greater than 80 is a screen for the output. If I didn't have that, the output of the walk forward input explorer would consist of hundreds and hundreds of thousands of lines. If I put R2 greater than 80, then I only want to look at the lines of the output that have a correlation coefficient of the out-of-sample data greater than 80. I don't want to look at lines that don't have metrics that don't have a correlation coefficient greater than 80. Also, I break even less than 200. I don't want to look at out-of-sample filters that have break evens greater than 200. In this particular case, we're looking at weeks. So if the break even is greater than 200 weeks, that's like 4 years. So I want to eliminate all those lines. The cost for the SPY 5-round trip was $4. OOSN is a special meaning. When I look at the out-of-sample data output from the Walk Forward Input Explorer, I want to see if the filter that I choose is from a certain set of data will work on 52 weeks following. So what I do is I exclude 52 weeks from the Walk Forward Input Explorer run. I choose best filter from the data that doesn't have those 52 weeks. And then I examine would I have been profitable using that filter in the next 52 weeks. So that's what that does. We've entered all the numbers we need to run. The next step is I click on run. And as you can see, the data goes from 108.0208 to 118.1207. An input files check shows that I have 414 calculation dates and then 52 out of sample dates that I withheld. I have a total number of filters of 193,536. It asked me if I want to proceed. And then, so when I click yes, it starts calculating. First, it initializes a giant array with those 193 different filters so that it could just, as it goes through, place each one of those individual filters in its individual bin. This takes a few seconds. The larger the number of filters we're examining, the longer it takes. We'll wait because I want to show you some other aspects of this, and then I'll stop and then come back when it's all done. This is being run on my laptop. Now it's starting to look at the various working files. So the estimated time left is really not the estimated time because it spent a lot of time setting up that giant matrix. So after we get to, maybe the 20th file, then we'll get a better estimate of the time. It should run, maybe this is on my laptop, which isn't as fast as my desktop, about half speed. So this will take a lot longer than my desktop. I think my desktop, ran this file in, half the time that you're seeing here. It's definitely not going to take 3 hours. But as you see, as the numbers go up, the less time it will take because I think it took 4 or 5 minutes just set up that giant matrix, which basically saves a lot of time. So it looks like it is settling in. And it looks like this run is going to take 2 hours. The estimated time left is getting shorter and shorter, not only because it's read all these files, but because the first 5 minutes has really been eliminated over 40 files. Anyway, so this looks like it's going to pretty much run an hour and a half. So I'm going to pause here, and then we'll come back when this run is finished. I'm back. As you can see, the Walk Forward Input Explorer is finished. It took about an hour's time, and it has printed its output to the temp folder, and we'll be examining that output in just a second. In order to examine that output, we come up here to the app file, click its icon, and then it loads into Excel, and it comes right. The app file that the Walk Forward Input Explorer generated has been loaded into Excel. The file name is the stub original stub that we had, IN for Input Explorer, AV for average, and A was that special letter that we put to designate what file this is. As you can see in the first 38 lines here, there are the various input filters. In other words, this first one says, well, the first line gives what the inputs are, which was N, V up, V down, XOP, XT, and multiplier. XT and multiplier didn't change, but it puts it there anyway. And then the profit factor less than a number and the KeyTells less than a number. So the very first filter generated a profit from 2808 to 1208 to 17, which was last year. Generated a profit of net profit of 18,101. Total net profits before commission at 26,605. When we go all the way over here to this line here, this is the 52 weeks that were not included in the original run. So it's interesting to see if this thing continued to make profits, which, as you can see, almost all these filters, in at least the first 38, actually did. This had, profit for this particular year of 6,559. Net profits of 4,455, an average of $12 per trade, an average of 10.5 trades per week, and it traded 50 of the 52 weeks. This thing traded, this number here, 441 weeks out of a total of 514. So as you can see, this filter did limit some of the weeks that it traded. Hopefully those weeks gave a higher profit. If they didn't, then we would see this set of inputs with no filter being better than with a filter. And we don't see that down here. Almost all these have a filter, so that is proof that this filter was effective in increasing the profits of the particular set of inputs. Next, we'll examine what all these metrics mean and how I choose the best filter to proceed in real-time trading.